Hey guys, I'm going to do a kind of a unique video here. I'm showing off some of my hobbies. I might start a new channel now that I think about it. One of my passions is music. I'm a musician. I've been playing guitar practically my whole life. And I've always liked to build things. And technology fascinates me. So what I've done is I've combined my hobbies, and I've taken my love of music and my love of building things and combined them together. So one of the things I do is I like to, as a guitar player, there's lots of effects you can buy, like stomp boxes or guitar pedals. And recently it was the 50th anniversary of the Crybaby, which is, you know, famous with Jimi Hendrix and stuff like that. And it was also the very first pedal that I ripped apart and modified and got it to work. A little shaky here, I'm just holding the camera. So what I've started doing is going out and buying parts and circuit boards and creating my own pedals from scratch. And this is a little shot of my little work area that I just set up again. I've had this hobby on hold for about 10 years and I just picked it back up again. This is where I build them. This is my desk with my drawers filled with components like resistors and capacitors and transistors and little integrated circuits and the hardware like the enclosures, switches, wiring and stuff like that. So I thought I'd just give you a rundown on how I do this and how I organize this and give you a little show on how it's all done. And the drawers there, I was going to walk a little forward here and I'm going to grab a seat here. I got my computer monitor set up here, and I got room on my desk for my laptop if I want to lay my laptop down and hook it up to the monitor if I want. I've got a little tiny computer the size of a credit card that I can just hook up to that with the speakers and a keyboard and a mouse, and you know, if I want to just go on the web right quick or something. But I use my computer for my instructions and things like that. I keep track of a database of what I have for parts and components and things like here. And over here, these drawers are all filled with my resistors. You know, I'll pull one out here. Here's one. Here's a drawer here. It has some different resistors in it. Different values, different tolerance, things like that, different wattage. I got them all labeled, and I got them all inventory down towards the bottom. So I got some hardware down here, and some potentiometers that I use, the dials, you know, the little knobs. Maybe it'll focus. Nah, it's not going to focus. Focus. Nope, won't do it. Anyway, just an idea of some of the components that I have there, and more hardware. There's some 1/4-inch jacks. Plug your guitar cables in. Things like that. Over on this side, I have in these drawers up top is all my capacitors. There's some drawer capacitors. These are film caps, different values. I'll give you a little rundown in a bit there of what they're all used for and how they all work in guitar pedals. I've got some electrolytic aluminum capacitors here. You know, and I go online and I buy all the parts. I see what I need and I buy the parts from a place like DigiKey. You can buy individual components like this. You know, you could build a brain from all the stuff they got on their site. You could build a motherboard, you know. Here's some switches that I have in that drawer. I use those for changing components, for modifying things like that. There's some drawers with some other stuff in it. And move the light here. There's some of the tools that I use, like pliers, needle nose pliers, and screwdrivers, wire cutters. Got to have a magnifying glass. You need one of these to read them. Here's my little solder iron, some power, 9-volt adapter for testing and stuff. And I use this for, I wet that down and you roll it on a wet thing when it's on to keep that tip. You see that tip's it's tinned, so it's not on, but you know, you got to have the tip covered with solder make a good joint, and then you got to clean it off on a wet thing. That's what I use. And got to have things like that. Some pens and stuff in here. Yeah, so this flashlight. Got to have a flashlight. There's my multi-tester. When I'm building stuff, I align all my parts in here, and I sort them all out, and there's my resistors and things like that, and I lay them all down in there before I solder them and stuff like that. And then I do my work here. There's some pedals I'm working on, some finished ones, some ones that need repairs and things like that. I'm going to pause the video here. I'm going to mount it in a tripod and give you a close-up and give you an idea how this all works. Alright, so I'm going to show you some of the tools that I use. They're easy tools. It's a really cheap hobby to get into. I used to work at the hospital and got a few of these. These come in handy. You can clamp if you want to clamp things down, stuff like that. And I got different tips and stuff like that, so they come in handy. Something like this is great for pointing. Pointing, things like that. It's good for digging and poking. Screwdrivers, different pliers. It's good for screwing nuts on. This comes in handy for grabbing and bending and things, needle nose, wire cutters, little snippers, side cutters for clipping the sides, and these are my wire cutters, and I used it for stripping the wire and stuff like that. And they come in handy and for things like that. Move them out of the way. Of course, your solder iron, all that kind of stuff. I've got a box on the floor here filled with spools of wire and things like that, and you got a cheap little, this is just a cheap little multi-tester, really cheap. And I've got DC voltage, I've got for resistance up to 2 mega ohms. That's a diode tester. It shows you the minimum current to go through a diode. DC amps, and AC volts, things like that. Some of the common components you use are things like that. I have little drawers filled with resistors. I'll get a light here. It'll focus better probably. No, maybe not. So there's some different resistors. These are quite common. They're 100K. I can take a resistor and I could turn this to say, put that on 200K. It's reading out of limit. I'll just clip one side here like that and put that there, and you can see now that's going to change. This is a 5% tolerance, so it's going to be within 5% of 100K, and it's at 98.9, so it's only off by roughly 1%. So even though these are all 100K resistors, this one here is going to be a little different, even though it's exactly the same. And that's what the tolerance is on the resistors. See, that one's reading different, 98.6, 98.7. You can see how I'm doing it here. So it's off by a little bit. However, the tolerance can be important. Those are half watts. This is a big one here. This is probably when I built a guitar amp. It's still 100K. If I hook it up to the meter, it'll still be 100K, but it can hold more current. So instead of a half a watt, this could be like 3 watts or something. And you can see that there's pretty close to 100K. It's within 5%, even though it's a great big guy. Those are resistors. I'll just turn that off. Another common component you'll find will be capacitors. These are ceramic disc capacitors. These things here, different values in the trays. And I got the drawer labeled on the front there, what's in them. Another common component. There's more different types of capacitors right there. Those are, these ones are film caps, different values. And again, I got them all put aside there, quite common. And these are also capacitors. Capacitors used in, these store electricity, but they also, in pedals, they help filter the sound, and they bring the highs and the lows through. And you can change these values and modify the circuits ever so slightly to get different sounds. These are, I don't know how to pronounce it, tantalum or something. They're a special, I'll get my needle nose out here and grab one or two. And these are coated, and I guess the whole purpose is that these guys here help, the coating helps keep them isolated from certain noises and stuff like that, because these circuits can get pretty noisy. So these are special capacitors that are used sometimes. Let me grab another drawer here. Let's grab the electrolytics. I got them somewhere. I don't know where they're at. Yeah, let's try these guys. These are some little electrolytic capacitors. I'm going to move this meter out of the way for now. Electrolytic capacitors, and they all do the same thing. Capacitors all basically store electricity, and they're used to help filter sound or help regulate, keep spikes of voltage from going through and things like that. They regulate the electricity flow and things like that. And really what it comes down to is the sound. These components are pretty cheap. Here's some transistors. Oops, I lost my little thing there. I just have little pieces of cardboard in my drawer here, as you can see, to keep them separated. I'll make sure. I always check my parts when I set them up. Different transistors, like JFETs, MOSFETs, and they're just basically switches, and they're little switches. They're like two diodes back to back. And there's some capacitors there. And what they do is they help amplify a signal. I won't get into the details, but it's one of the more common uses for transistors. And some of the pedals that I build, some of the stomp boxes, are like for distortion and things like that. And there's certain parts. I'm going to show you a little circuit board here, actually. This circuit board is this is for a rat distortion pedal, and these are capacitors go there. These are their diodes here, and these diodes help produce the distortion sound. And this here, I'll show you one of these, is an op amp. It's called an operational amplifier right there. Let me move that in a little closer so you can see it. Put the light on it, it may focus it better. This one's kind of hard to get right now. It's not in production. It's called an LM308, and it's, let me get it in there if it won't focus. It's a little 8-pin integrated circuit. It's an operational amplifier, so it amplifies the signal, and these are quite common in pedals. And for the rat pedal, this is apparently what gives it that classic sound. And these are kind of expensive now. They're about $5 each because they don't make them anymore. And people say, yeah, if that's it, that's the sound you want. You got to use that. You can replace them with different values and different ones, but it just doesn't give you the same sound, apparently. And that's where that goes there. But the diodes, I got a drawer of diodes out here. I want to try to show you something. Diodes are basically used to help create what's called the clipping effect. Now, I know I got them out here. I just don't know where I put them. Got so much stuff on my desk right now. So I'll grab another drawer of diodes. Here we go. So there's an example of some diodes, different value diodes. And a diode just allows electricity to pass in one direction, and there's a minimum voltage. It's like a gate, it's like a release valve. So when the pressure builds to a certain, pressure will build up, and then all of a sudden it lets that pressure through. And that's how a diode works. Transistors are basically two diodes back to back. So the electricity comes in one end, but it won't pass until it reaches a certain value. So I'll hook it up to the meter and I'll show you what I mean. So I'll set my meter diode. I'm pretty sure I'm correct on this because I have no idea what I'm doing. I learned all this on the internet. So the negative end will go on this side of the diode. And I'll just grab this here and we'll hook that up. Now as you can see, it takes 0.929 volts to allow electricity to go through. So if I only had a half a volt of electricity, this end would not be getting any power. So it wouldn't travel. So if the voltage was lower than that, nothing gets through. But that's what the minimum voltage is. So it's like a pressure valve. Then it lets it come through. And they're used in stomp boxes, and especially with distortions. That's basically how you create the tone of the distortion. And you can, with these circuits, you can modify the hell out of them. So I could put, instead of soldering, like right here on this board, I don't know what I do with my pointer, I got so much stuff there. Now, instead of putting the diodes right on the board right here, what I can do is just solder a wire here. And then I could use a switch like this. So I can take a switch, and just basically has, this one has 3 positions, but you know, sometimes they only have 2. This is called a double pole, double throw. So there's 2 switches back to back. Okay, so either put it in the middle, and then this is where your wire goes in the middle. Then on this side, you have a component that goes over here. So here's your in. Let's say this is very basic now on how this would work. I lost my little pointy thing. Here it is. So basically how this switch would work is right here would be, let's say this is your input. Then I could have a diode connected here to there, and that's your output. So when the switch is in this position on this side, what happens is the signal comes in, goes through that diode, goes back out onto the board. So it goes from here to here, through there, and then back to there. And then I could have a different value diode on that side doing the same thing. So when the switch is in this position, the signal comes in, goes through that diode to that pole, out of this pole, and back onto the board. So then you could just flick the switch and change the setting. And that's basically, you know, one of the fun things about doing this is I can create that, and it's, you know, you just put something in, listen to it, see how it sounds. If you don't like it, take it out, put something else in. It's quite simple. You can get these boards. There's lots of different places that make these boards. For guitar guys, quite common. And you know, it looks like a switch right there. It must be where a switch gets soldered in. I'll have to check the instructions for this one. And there's where you hook up your, you know, your jacks and your power and the dials, like your gain and your volume and things like that. And there's the output, and there's where the LED and things like this, another jack, and you know, your current goes through. And these are what's called true bypass. So basically, when the pedal's turned off, the signal does not travel through here. It uses a mechanical switch instead of, like, I think it's called MOSFET switching. Instead of using transistors where the current or the signal is always going through this board, the way I do the pedals, which is quite common, is it doesn't, when the pedal is off, when it's not stomped down, the LED's not on, the signal just goes from one wire to the next and right back out. It's like having a cable. Then when you hit the switch, it mechanically puts the circuit into the loop. So that's what true bypass is. So yeah, you can get them circuit boards, lots of different places. You can buy complete kits. So here's an empty, this is a box. This would be like a finished one here. That's a phaser, an MXR Phase 90, and it sounds fantastic. You can't buy them anymore. They're old pedals, the same as these rats, so you can't buy them. And the reproductions they make aren't the same. And you can build them for a fraction of the cost. Okay, so there, the signal would be, let's say the signal would be going right through here right now. Then I click it in, then it goes through the circuit back out. I do that, and it only goes straight through. So this is a Phase 90, a phaser. It's a filter effect, and it sounds fantastic. Think of some Dark Side of the Moon, Us and Them kind of thing. An example of that. Here would be this is an old delay pedal. This is here's the inside of it. This is a delay pedal. I'll put the light on it. And basically this is an analog delay. So in here you can see it's all soldered up, and here's our film caps. Here's a ceramic cap, some little electrolytic capacitors, and all the resistors. These blue ones are 1% quarter watt. It's like a timing circuit or something, I believe. There it looks like a little operational amplifier, a little op amp. There's the input. They're backwards because it's upside down. The jack, power. Signal comes in, goes through the switch, back out. When you engage the switch, signal comes in, goes up to the board, and then back out. So that's what true bypass is. Alright, so it's a little delay. So an analog delay would be every time it repeats, it's like bam, 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 and it slowly fades off. But with this, each repeat, it cuts a little bit of the low end off of the signal. And That's usually done by, it's called filtering, and the capacitors usually have something to do with that. Different value capacitors can change that. And it's supposed to resemble what's called a tape delay. So back in the 60s and 70s, the delays were big tape machines, so like reel-to-reel tapes, and that's how they worked. And tapes lose the signal every repeat. It degrades the signal, and that, instead of a digital delay that does it digitally, and that's kind of an analog delay, it sort of creates the same effect. Here's a bare box tremolo. It's not done up, and I got some holes in it if I wanted to add some switches to modify it. A little basic circuit, same thing. This part here is all the same. You know, there's the board, and yeah, it's just a tremolo pedal. That's your, I think your mix, your wet and dry. And this would be your rate. You know, and this is a great one here. This is a TS808 tube screamer, and it sounds fantastic. This one's modded. I have asymmetrical clipping in this one, and I have all tube amps. I built a tube amp. I have all Marshall tube amps. In the UK, it would be a valve amp. They call them valves. Like a little tube here. There's a preamp tube. Just put that light down for a sec. That's what I mean by tubes. It's a Marshall tube, Marshall branded. See, ECC83. That's the British version, and the American version is 12AX7, which is the same thing. So this is like a transistor. It's like a valve. Does the same thing. Takes a weak signal and amplifies it. And when it comes to guitars, then this is it. This is how you get that great sound. It's tube amps. And a lot of my pedals work best on tube amps. I don't know. They just sound better. Here's a diagram, and this is kind of how I started in the modifying stuff. I have an old Crybaby from, Dunlop Crybaby from the 80s, and it has one of the components. Here's a little diagram of the board that I drew. It has a stack of dimes inducer, and then here's my resistors and capacitors, some transistors, and I wrote the values here. So R1 is a 33K resistor. So on here we find R1 right there, that's 33K. And then here's how it was. There's my voltage coming in, all the different wires that that connect here. And then there's the jacks, the input jacks, that's the sweeper, and that's the switch. So I wanted to modify it. So there's what I have is a GCB95, and this is what it looks like unmodified, all the wiring and stuff. It's not a schematic, it's just a diagram to show me what it was originally. So then what I did is I did this, and I changed the switch, double pole, double throw, and that allows it to be true bypass. So then when the pedal is off, the signal goes right from one to the other, like that. It doesn't go through the board. So when it's engaged, it would go down to here, blah, 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 through the circuit, and then out here. So when it's off, it's just boom, true bypass. It's supposed to, when the effect is off, it's supposed to give you a truer sound. Tube amplifiers especially can really pick that up. And then down here's a list of the mods that I did to it and what values to change. Vocal mod, so I replaced the R1 resistor from a 33 to a 68K. And this is my favorite, the gain and bass response. So when you toe it, when you go towards the toe, it gives you more gain in the tube amp. You can really hear that boost. So replaced R6 from a 470 ohm to a 220 ohm. And then a mid-range mod, I think they call it a Q or something, that replace R4 from 1K5 to 2K7. That's basically three little components I changed, and changed the wiring and the switch. Changed the wiring and the switch, and that was my first taste of modifying guitar effects. Oh, bumped it there. Here's a Crybaby that I built. Get some light on it. I see this light's a little bit more. Let me get that up there, a little shadowy. So here's a Crybaby that I built. It's based on a Vox McCoy, I think. There's the board here, there's the inducer. And I've got some modifications on this one. Here's an example of how the switches work on these. So you can see it's just like my diagram. This is a triple pole double throw, but I'm not using this rail here because there's no LED. So I just need to use these two right here. And that's true bypass. And basically how Crybaby works is this is the top, and you put your foot on it, and as you sweep it, it goes like that. And that's how this potentiometer moves here. As you can see it move when it goes up and down, changes the value, and the wires go into the board. Move that battery thing there. So this one's got some old school. These transistors are probably 60 years old, 70 years old. You wouldn't be able to buy them, and that's one of the part of the fun of doing this. There's some different resistors and caps in there, and some of the modifications I did to this one was right here. I have a switch with these two capacitors on it. So right here, instead of soldering the capacitor to the board, I have two wires, and they go into the middle. And then if it's in this position, it uses this capacitor, and the signal comes back out this wire. I only have a single pole switch in here, single pole double throw. So that means single pole, it only has one rail and two positions. So it either on this side or that side. Signal comes in the middle. On this position, it goes out here through this leg into the capacitor, and then I got a wire soldered down to the other leg. So both capacitors, one leg soldered together with a wire coming off of them. And this is for what's called, it's kind of like, it just gives you a different tone. You know, it's hard to explain. You got to really hear it. So it comes out of this wire, or one of them, comes out of one wire into the switch through this end, and then back into that pole, into that pad or that spot right there. If I flick it this way, it's using this capacitor. And that's how you basically do this with capacitors or resistors or diodes and distortion pedals to modify it. Instead of changing the parts, just go bam, bam. And you could have a rotary switch with tons of these on it. The switch is broken. I got to replace it. I got some on order. And what this switch is doing is these gray wires, and there's a spot on the board for this. It's for the buffer. This is for filtering, and this is the buffer. And what the buffer does is it helps keep your signal from degrading when it's not engaged. So I can either have the filtering on or off, and that's all this does. Instead of having it permanent to the board, like, you know, by soldering it up and saying there now the filter's always on or the filter's always off, I can choose it with the switch just to see what I like best. And different amps sounds different, same as this. Different amps are going to sound different. And this I can change the bass, middle, and the treble. This is for what's called the Q. It's kind of the voicing of the pedal. And this is for the buffer signal, the volume on the buffer. And this is a great little simple kit to build. You can easily modify it. And got some neat wiring in there. I'm just going to replace that switch. So yeah, that's basically my pedal building in a nutshell. This is where I keep all my components in here. When I'm building a project, I'll put different things in here, lay them all out, pick my parts out, stuff like that. Here's a cool little thing I do with resistors. They're so hard to read. So I'll take this here. It's a piece of corrugated cardboard. I just put a piece of tape on the top, and then I write values here. So then I could just take a, well, this is like as an example, here's a capacitor, but it's, say this was a 22K resistor, I just stick it in here like that. I just put one of the legs in like that and go, there we go. So all these would be all my 22Ks, and I'll measure them all to make sure they're correct before I start, because you don't want to make a mistake, find it after you solder it all together. And then I pull it out and I solder it on the board. Oh shit, now where did I grab that from? See, so this is why you need the magnifying glass. So I can't read that. It says 102 on it. So that would be 1.001, 0.001 microfarads or whatever they're called. That goes there. So yeah, that's how I kind of get all my parts together and stuff, and I solder them all together. Then of course you hook them up and play them and see how they sound. So that's it. It's kind of how I do my pedals. And some of the end products here, some of the guts. There's a tremolo. And there's the delay. Ooh. There's a tube screamer. This is a, what do I call that? I think that's a big muff. Fuzz and distortion. Sounds great. I like the sound of that. I just paint them. Sand the boxes and stuff. But yeah, so that's basically how it works. And I really enjoy it. I might put some more videos up. I might do some sound clips. I'm not really sure, but anyway, that's how I build guitar pedals. And it's quite rewarding. It's fairly cheap, and you know, people actually buy these things from me. I've sold them to people. I've built guitar effects. I've built tube amplifiers, and you know, they sound fantastic. Anyway, Who knows, this may be a new thing for me now. Anyway, thanks for watching. Everyone take care and rock on.